All right, welcome to the Explainer. Today, we are cracking open the universe's instruction manual. We're talking about the super simple, super elegant rules that control how everything, and I mean everything, moves, from planets to cars to the phone in your hand. So, let's start with a really basic question. Why does a book on your desk just sit there? And what does it actually take to make it move? It seems almost too simple to ask, but answering this question is the key to understanding, well, pretty much everything. And here's the best way to think about it. The universe kind of has its own operating system. It's a set of fundamental rules, the principles of dynamics, that just run in the background, making sure everything behaves predictably. And once you know the code, you can see what's coming next. Okay, let's dive into the first principle. I like to call this one the lazy law, because honestly, it describes the default setting for every single object everywhere. It's what things do when nothing else is going on. Officially, this is the principle of inertia. And it basically says that objects are, well, lazy. They're stubborn. They want to keep doing whatever it is they're already doing. If an object is just sitting still, it wants to stay still. If it's moving, it wants to keep moving. It will not change its state on its own, ever. Now, here's where it gets really interesting. On the left, you've got an object that's not moving at all. On the right, you have an object in what's called moto rettilineo uniforme. That's just a fancy way of saying it's moving in a perfectly straight line at a constant, steady speed. Now, here's the mind-blowing part. To physics, these two states are basically identical. Why? Because in both cases, nothing is changing. They're both in a state of perfect, unshakable inertia. And for this idea, we have to give a huge shout out to Galileo. Before him, everyone thought you needed a constant push to keep something moving. But Galileo realized, nope, an object's natural state is to just keep on coasting. That was a total game changer, and it set the stage for everything that came next. Okay, so if everything is naturally lazy, how does anything ever happen? How do we ever get that book to move or stop a ball from rolling? Well, that brings us right to our second principle, which is all about the one thing that can shake things up. And that agent of change is called a force, or forza, if you want to be classic about it. It's really that simple. A force is just a push or a pull. Anytime you see something speed up, slow down, or turn a corner, you can bet a force is behind it. It's the only thing in the universe that can overcome inertia. So how much inertia does something have? How do you measure its laziness? That's where mass comes in. Now, mass is not weight. We'll get to that. Mass is the actual measurement of an object's resistance to change. The more mass something has, the harder you have to push it to get it to do something new.
And when a force is strong enough to overcome an object's mass, what you get is acceleration. But be careful here. We usually think acceleration just means speeding up. In physics, it means any change in motion. Slamming on the brakes? That's acceleration. Taking a turn in your car, even if you keep the same speed, that's acceleration too, because you're changing your direction. It's any deviation from that lazy, straight-line path.
And this table shows the magic relationship, which you probably know as F equals ma. It's super intuitive. If you use the same amount of force on two objects, the one with the big mass is going to have a small acceleration. The one with the small mass gets a big acceleration, right? Give a bowling ball and a tennis ball the same exact push. The tennis ball is going to take off way faster because it has less mass, less inertia to overcome.
Now let's talk about an acceleration you're feeling right now, gravity. Here on Earth, if we ignore air, every single object that falls accelerates downward at this rate, 9.8 meters per second, faster every second. It's one of the most constant forces in our lives.
And that brings us to the difference between mass and weight. Your weight, or peso, is literally the force of gravity pulling on your mass. Your mass, your laziness, is the same no matter where you are in the universe. But your weight? That would be way less on the moon, because the moon's gravity is weaker, so it's pulling on you with less force. So we have the default state, inertia. We have the agent of change, force. But there is one final, really profound rule. The third principle isn't just about happenings to an object. It's about the nature of forces themselves. So let's stick with that rocket. To launch, it has to do something first. It performs an action. It shoots hot gas down, pushing it away with incredible force. But here's the thing about forces. They never act alone. For every single action, there is an equal and opposite reaction. As the rocket pushes the gas down, the gas pushes the rocket up with the exact same amount of force. And that's what gives us liftoff. Forces always come in pairs. And once you know to look for it, you see this action-reaction dance everywhere. It's obvious in jet propulsion or a cannon firing, but it's also how you walk. Your foot pushes backward on the earth, and in reaction, the earth pushes you forward. Even a book just sitting on a table is in a quiet battle. Gravity pulls it down, and the table pushes it up with an equal force. Now, a quick little footnote, but it's an important one. This whole system, these three laws, they work perfectly as long as you, the person watching, aren't accelerating. Physicists call this an inertial system. So whether you're standing still or on a train moving at a perfectly constant speed, these laws are the absolute truth. And there we have it. The law of laziness, the rule of force and change, and the law of action-reaction pairs. You put those three together and you have the fundamental laws of dynamics. It's a complete toolkit for understanding and predicting pretty much all motion in the universe. It's beautiful. So I'll leave you with one last question to put it all together. The third principle says the forces are equal. The apple pulls on the earth with the exact same force that the earth pulls on the apple. So why do we only see the apple move? Why doesn't the earth come rushing up to meet it? Well, think back to principle 2, F equals ma. The force is the same, sure, but those masses, they're just a little bit different. Thanks for watching.